Okay, this is Mr. Peterson continuing the notes for section 3.1, and this is part F, which on my example here is on page 5, but I believe is possibly on page 4 of your note set. At any rate, what we're going to learn how to do is find relative maximums and minimums. Now, a word of explanation. A maximum and a minimum in this case refer to the height of a hill or the bottom height of the valley. So one is a maximum, relative maximum height. The reason we put this word in front is because we really don't know what this function does. It might curve around like this and go up forever, in which case this height of 3 really is not the highest point on the graph. But if you just have, I guess, near vision, you can only see right around it, and that 3 is the height of that hill, and that's called a relative maximum. To tell if it's a relative maximum, you just have to be increasing on one side, and then when you get past it, decreasing on the other, the right-hand side. By contrast, a minimum height, relative minimum height, you're looking for a valley, and as you're going from left to right, it goes downhill first, and then when it gets down there, it turns around and starts going back uphill. And here, the minimum height is the y value is -2. These maxes and mins are always y values. So you essentially ignore the x value. Okay, so I'm going to give you an example where we can just, by inspection, estimate that max or minimum height. And I'm going to first of all highlight the maximums in pink here on those two examples. And I will highlight the minimums, the relative minimums, in kind of a blue-green color here, light aqua. And this last part, example B, has 2 relative minimums. All right, so let's find the maximums first. Remember that we're looking for y values, and the best we can do is approximate. So maximum, let me spell that correctly, is the y value is approximately. Okay, so looking at the height of this point here, you can see that it's between 4 and 5, so you do your best to get within maybe 1/10 of the accurate answer. I'm just going to say 4.4 on that one. On the other side, this one up here is at a height of about 3.2, and since we're estimating, your teacher has to give you some wiggle room of maybe about 1/10, so I would say 3.1 to 3.3 would all be acceptable. All right, now we'll switch to those light green ones, and those are going to be minimums. There's 1 on this one, and you can use the squiggly equal sign to say approximately equal to, and that the height of that point down there is about -2.4. A little hard to get dogmatic on that because we can't tell by just looking at the graph. Now this one, the next one, example B, has 2 minimums, so let's set that up. So this one over here, I'll call that the first one, is at about -3. I'm going to go with -3.8. And this one over here is roughly 1.9. Remember, it's the y value you're looking for because these are minimum and maximum heights, and y values are heights. Okay, now there's a way to find it more accurately on the calculator. You won't be estimating quite as radically on here. You still will have to round off, so you'll see me use that squiggly equal sign. There is another example, another way to write approximately equal to. I'll show you that on one of these examples also. So I'm going to go ahead and give you the answers to number 9, and then I'm going to take you through a series of pictures in a separate file, and that'll be another video, where I show you how to find these answers that I'm going to list right now. So I'm going to try to show you this in picture format on a separate video. I'll title that one Examples 9A and 9B from Notes 3.1 or something like that. Okay, so if you graph this function, you'll get a graph that looks something like this. And it's going to have one maximum and one minimum. And the height of those points is going to work out. We're going to find out with more accuracy than just guessing by looking at a picture. The first is at a height of approximately 1.28. And again, I'll show you how I come up with these numbers later. And the second one is at approximately negative 2.28. Okay, then we're going to get another graph that looks something like this on this next one. And it's going to have one maximum and two minimum heights. So that hilltop right there is the maximum, and these two lower ones are the minimums. Okay, so I'm going to list this. It's going to be one maximum, and here's the other symbol for approximately equal to, and two minimums, two valleys, and the maximum is at a height about negative 3.69 when you round it. And the minimum, for one of the minimums is at negative 6.07, and the other one's going to be negative 7.04. Okay, so that's the answers to this one. I obviously haven't shown you how to get those yet, and I'm just going to go ahead and quit this video and make another video just for problems 9A and 9B, where I show you all the steps on the Texas Instruments 84 calculator.